This will be the style that you will see for notes in this class. In other words, we'll start off with usually a half a page, sometimes a whole page that'll give you the most important concepts within the section. May include some examples of how to be solved in that section, and then we will end with a number of examples in which I will work them out so that you can see how these problems are worked out. But in general, this is the style that you'll see. So for our first section, this is about solving linear equations. Basically, the idea is you want to simplify the equation. If there are fractions, you want to get rid of those fractions. You want to remove all the parentheses, combine like terms. Then we want to make sure that all variables are on one side of the equation and the constant terms are on the other side. This can be done by adding or subtracting the same term from both sides. And we again will combine like terms. And then commonly we do put the variables on the left and the constants on the right. It's not really a rule, but that's generally how it's done. So, for example, here we have 2/3 x minus 5/6 equals 1/2, which, if we just multiply everybody by 6, instead of looking at an equation like this, we look at one that's like that. It's not a required step, but by just doing that one little extra step, we now have a problem that's much easier to solve. So we add 5 to both sides to move the -5 over to the other side. Basically, anytime you move something to the other side, you change its sign. So 3 and 5 will give you the 8. So 4x will equal 8. Then we divide both sides by the 2, and we end up with, or by the 4, and we end up with x equals 2 for our answer. So another example here, we have 3x plus 7 equals 7x minus 9. So we want to get all the x's on the left, and likewise all the numbers on the right. And so note here, we had 7x, moved it to the left side, became negative 7x. Here we had a 7, move it to the right side, it became a negative 7. Now we can combine our like terms. 3 minus the 7x is negative 4x equals the negative 16. Divide both sides by the negative 4, and we have our answer. So in general, that is what we want to do. Now let's look at some examples. So first off, okay, I want to get all the numbers together. So negative 29 plus a 17 is going to equal 6b. So note that I moved the 17 to the other side, so it was negative 17 on the right, became positive 17 on the left. Combine these terms. Negative 12 equals 6b. Divide both sides by 6. And I'm going to end up with negative 2 equals b for my first answer. Now, in general, we tend to put the variable part on the left, but it is not required. So here we have negative 2 equals b, which is just fine. All right, next, I have some fractions. Don't like fractions. Let's get rid of the fractions. So I'm going to multiply everybody by 40. How'd I get 40? 40 is the number that 5 and 8 and 10 all go into. I didn't really try to find the lowest none that they all go into. This does happen to be it, but 5 and 8 gave me the 40, and I know that 10 also goes into 40. Now, by multiplying everybody by the 40, first off, 40 divided by 5 will be 8. 8 times 2 will give me 16. 40 divided by the 8 will be 5. 5 times the 3 will give me 15m. And then the negative 11 over 10 times the 40 will give me negative 44, since 40 over 10 is 4. We're now going to move the 16 to the other side, so negative 15m will equal negative 60. Now divide both sides by the negative 15, and we get 4 as our answer for the second one. Again, we started with this, but multiplying everybody by 40 made it a much simpler problem. Okay, next, we've got a bunch of parentheses, so we want to get rid of all of them by distributing. So, first off, we're going to have 3 times the 2, that'll give me 6x, 3 times the negative 8, negative 24, negative 5 times the 15, negative 75, negative 5 times the negative 6, plus 30x. It's going to equal 36x, 9 times 4, and then subtract 99. Most common mistake, by the way, in these kinds of problems is when you do have a negative number, if you will, outside of the parentheses. Very often a student will take care of the first one, so negative 5 times the 15 does give me negative 75, but will not always do the second one as well, and so we have a negative 5 and a negative 6 to give me my positive 30. Okay, now we can combine our like terms. 6 and 30 gives me 36x. Subtract the 99, 24 and 75. Over here, we didn't have to combine anything. And, oh, I noticed I have the same things on both sides. So if I move the 36 over by subtracting, I would end up with no x's. And if I add 99 to both sides, I'm not going to end up with any constant term either. In fact, I'm just going to end up with 0 equals 0. Now, this is a true statement, which means since all my x's have been eliminated, the actual answer is all real numbers. In other words, any x I put into this equation will, in fact, give me an answer that works, because I'll end up canceling everything out. Okay, next, some more parentheses. So we'll distribute 3 times the 4, 12y, 3 times the negative 5, negative 15, plus 2y, plus 20, equals 18y, subtract 12, subtract 4y, negative 4 times the 2, negative 8 here. Okay, combine like terms. 12 and 2 gives me 14y. Negative 15 and 20 gives me plus 5. Over here, 18 subtract the 4y gives me 14y. Negative 12, negative 8 gives me negative 20. Now, when I move the 14y to the other side by subtracting 14y from both sides, I end up with 5 equals negative 20, which is not true. I have eliminated all my x's, and yet I've ended up with a statement that's not true. And so in this case, unlike part C, I end up with the empty set, no solution. In other words, there is no x that will make this true. All right, now, next one, I have some decimals, and I like to treat decimals like fractions. In other words, let's get rid of the decimals. So I note that this is the tenths place, tenths place, tenths place, and tenths place. So I'm just going to take everybody and multiply it by 10. Now again, this is not a step that you have to do. It's just a step that can make the problem easier visually to look at. So multiplying everybody by 10 gives me 32x plus 83 equals 13x plus 197. Now again, it's not really different from what it was, but it can make things easier to look at without the decimals. Okay, we're going to Subtract 13x from both sides, which will give me 19x. We're going to subtract 83 from both sides, essentially moving it to the other side, so it's positive here. Subtract over there, it gives me 114. Divide both sides by the 19, and I end up with x is 6 for my answer. Okay, now here I have decimals again, but some of them have just one decimal place and some of them have two decimal places. So in this case, I'm going to multiply everybody by 100. So that'll give me 30x plus 55 times 95, subtract x, equals 4275. Please note, I did not change the 95, just the 0.55 that was outside of the parentheses. If I was changing the 95, I'd end up changing both of them, and I only want to change one of them by multiplying everybody by 100. Okay, now let's distribute 30x plus 5225, subtract 55x, and equals 4275 still. So again, ignore that, that's just an equal sign, that's 55x. 30 subtract the 55 will give me negative 25x. Move the 5225 to the other side by subtracting will give me negative 950. Divide both sides by the negative 25, and I end up with 38 as my answer. All right, 2 to go. First off, I have not only x's, but I have some other variables that have not been defined at this point. That's okay. None of the rules change just because I have 2a and the c involved. So first off, we're going to do some distributive to get rid of the parentheses. So 5x subtract 2a subtract c will equal 4x plus 4c. Go ahead and subtract the 4x from both sides, and now I have this. And then I can move the 2a and the c, which are negative on this side, put them on the other side. And so I'll go ahead and write out all the steps, 2a plus c plus the 4c that was already there. Now we just want to combine the two c terms. And there is my answer. And then, once again, I want to get rid of the fraction, so I'm going to go ahead and multiply both sides by the 2a. So over here, that'll get rid of 2a over 2a is 1. Anything divided by itself is 1. Leaves me with just the x minus 1. And then on this side, I have 2a times the 2x, so 4ax. And then the other one, 2a times the negative a, subtract 2a squared. Now, got an x here and an x there, so let's move things around. X subtract 4ax equals 1 subtract 2a squared. So note I moved negative 1 here, became positive 1 on the right. The positive 4ax became negative 4ax on the left. Now let's factor out the x. to give us that. And then divide both sides by the 1 minus 4a, and we end up with that is our answer. And let me finish by noting that I cannot cancel the 2 with the 4 or the a squared with the a because they are binomials. In other words, there's 2 terms here, and only when a factor is in all of the terms in the numerator and in the denominator can I do any canceling. So I cannot cancel out the 1s, I cannot cancel out the 2 and the 4 and the a squared and a. That is my final answer. And so there is section 1.1.